Next, let's take a look at when we have the subtraction sign in between. So we have negative 10 minus the square root of 160. Go ahead and press enter now. Then we can divide that by negative 10. Go ahead and turn that into a decimal. And it looks like one of our x-intercepts is at 2.26 seconds. Now remember, in the context of this word problem, okay, the negative 0.26 seconds really doesn't make sense. Okay, or maybe you can consider that her walk up the ladder, okay, to the high dive or to the springboard. But the diver is going to hit the water in 2.26 seconds. When does a diver reach the peak of the dive, and what is the peak of the dive? Okay, in order to find this, we are going to need to calculate the value negative b over 2a. Our b value is 10, so we have negative 10 divided by 2 times negative 5. So that's negative 10 divided by negative 10, giving us 1. So when does the diver reach the peak? Okay, 1 second later, the diver reaches the peak. All right, then it says, what is the peak of the dive? To find this, we can input 1 into the given quadratic, but since I've already looked at the table, when I input 1, my output is 8. So it looks like at a height of 8 meters. Now it says draw a sketch of the graph. Okay, because there are no units given, we can go ahead and create our own. Okay, given that it hits the water somewhere in between 2 and 3 seconds, right about 2.26, we really only need this to max out at 3 seconds. So 1, 2, 3, and I'm just going to label this as seconds in the scenario. Okay, then it's reaching a maximum height of 8. So let's count by ones here. Okay, so 0 seconds into the situation, the springboard is at an initial height of 3 meters. So we'll put a dot here. 1 second into the scenario, it's at a height of 8 meters. Okay, 2 seconds in, it's at a height of 3 meters again. And remember that maximum height happens right at 1 second. So it's turning down here, and then it reaches the 0 or the x-intercept at 2.26. So just barely past 2 seconds. And I will label my y-axis as height in meters. Okay, on to part E. What is an approximate domain for the scenario? What is an approximate range? Okay, remember domain is all of the possible x values. So we start at 0 seconds in, and then they hit the water at 2.2 seconds. If you wanted to make an argument for talking about her height below water, I would say that you could make an argument for the range being 0 to 3 if you think about how deep she goes into the water a second or two after going through. So that would be my domain. Okay, then an appropriate range for this scenario is your lowest y to your highest y. Okay, so the lowest y, well, we can make different arguments for it, but I'm going to make 2 arguments. Maybe you talk about her reaching a height of 0, which is when she hits the water. So 0 to a maximum height of 8 meters. Okay, or maybe you might make an argument for how many meters below the water she goes. Now we can look at the table. Obviously, she won't go below the water forever, but if you carry it down to 1 second later, maybe she does reach 12 meters below water. So I could see you making an argument for either scenario. Now let's look at the next page. If a punter kicks a football with an upward velocity of 70 feet per second, the function shown represents the height of the ball y after x seconds. Okay, so notice that the height of the ball is going to be feet. Okay, and it looks like time is represented in seconds. So the question asks, what is the initial, or what is the height of the ball when first punted? Look at the C value. That could tell us your initial height. Really, it's your y-intercept. Okay, so it looks like the initial height is 3 feet off the ground. Another way you could find this value is by making the table. So if we turn on our table feature and edit the function, in this case to negative 16x squared plus 70x plus 3, we can then create a table to look at. I'm going to copy the table onto our notes. Okay, 0 seconds in, it looks like it is at a height of 3 feet. 1 second in, it's at a height of 57 feet. 2 seconds in, it's at a height of 79 feet. Let's keep going. Oh, then it looks like it starts to go down from here. 3 seconds in, it's at a height of 69 feet. And 4 seconds in, it's at a height of 27 feet. And 5 seconds in, we're at a height of negative 47 feet, which I'm just going to make the note that really doesn't make sense in terms of the context. So we know somewhere in between 4 and 5 seconds is when this really hits the ground. Okay, how high was the ball for the football at its maximum height? Remember, we can do the calculation negative b over 2a, where my a value is negative 16, my b value is 70, and my c value is 3. So we have negative 70 divided by 2 times negative 16. If we crunch that number, it's approximately 2.19 seconds. So, how high was the ball? Well, this is the time it reached the maximum height. Now we need to find the exact height the exact height that it reaches. Well, notice that just after 2 seconds, right, we just barely increased past 179. So we could say at about 80 feet. Or if we wanted to give an exact answer, we would have to plug this value into this equation. So y is equal to negative 16 times 2.19 squared plus 70 times 2.19 plus 3. Let's punch that in and see what we get. And if we round that, it is right about at 80 feet. But if I wanted to give a better answer, it looks like it's approximately 79.56 feet. How high is a football after 4 seconds? Well, if you look at the table, 4 seconds in, it is at a height of 27 feet. And, last but not least, how long did the football travel in the air before it hit the ground? So, in order to find this, we're going to have to look for x-intercepts. And I'm going to use quadratic formula. We've already identified our a, b, and c, so now let's just plug it in. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. First thing we'll do is simplify the discriminant. Okay, underneath my radical, I'm given 5,092. Okay, and then on my denominator, I'm going to have negative 32. So we're going to look at two potential answers. One answer is negative 70 plus my square root divided by negative 32. My other answer is negative 70 minus my square root divided by negative 32. All right, let's plug this in our calculator and see what we get. We have negative 70 plus the square root of 5,092. Let's hit enter and divide that by negative 32. So this is negative 0.04. Then let's do the next calculation. Negative 70 minus my square root, minus my square root of 5,092. Hit enter, divided by negative 32. And just as we suspected, somewhere in between 4 and 5 seconds is when this ball hit the ground. Okay, so how long did it take the football, or how long did the football travel in the air before hitting the ground? It traveled in the air for approximately 4.42 seconds before hitting the ground. Good luck on your word problems. Go ahead and grab them from the substitute now.